that we provided with that, safety that we provided our daughter with was because of the impact products that we decided to invest. It's actually something very difficult to put a price tag on. So I just want you to please keep in mind that the safety that these, father, basically, let's not put any other title, right? That this father was able to provide his daughter with was thanks to a very humble, everyday material that we all take for granted, which is glass. And glass, by the way, of course, is actually the subject of my presentation today. And just so you know, by the way, once we get into the content, I'm just gonna disappear there so you can just focus on the presentation, and you will see the whole screen with my PowerPoint here. I'm the architectural representative, and I'm really honored and humbled to be part of a very committed and a highly professional group of people. I don't know if you know, but we also have our very own commercial specialist, that is Jack Britton, who actually covered the whole state of Florida. Then Megan Joseph is the representative who actually covers the Southwest Florida and specializing on residential sector, just like myself on the Southeast Florida market. There you can actually find our contact information. Please feel free to reach out to any of us, depending, where the project is at, and the characteristics of your project for any assistance. I just wanted to mention that we have in this market, in the market I cover, which goes from Vero Beach all the way to the Keys, we have 3 sales managers, 5 sales representatives, and over 50 certified dealers. This is just like many boots on the ground. And hopefully that will give you an idea of how committed we are in order to, really to make sure that if you trust us with your project, it will be delivered. That basically, that is the idea. And as this African proverb put in very simple words, but really share to me a very beautiful truth. If you want to go fast, go alone. But if you want to go far, go together. Okay, so as I mentioned before, we're actually going to start our presentation here. And hopefully I can find a way to, how do I do this? I love Zoom. You just have to, or maybe not. So anyhow, let me just start by going here to explain that basically this is just a AIA continuing education course. You're gonna take 1 credit, 1 hour credit, and for some reason I cannot. And this is actually going to be our agenda today. Now I have a little glass trivia for you, if this thing decides to work. What does Miami Beach and glass have in common? You might even participate, through the chat here, or just think it for me. If you said sand, you are correct, as 57% of actual raw material of glass is made out of sand. Now, this is really not the sand that you will find on the beach, but it's something called silica. And it's a very pure white sand that is used in this mix. Of course, we also need limestone, soda ash, and others. So this is just a little bit of history of glass. And as you can imagine, this is a very vast and fascinating topic by itself. I can easily spend an hour on this. Obviously, because of this presentation, we cannot do that. So the only thing that I want you to keep in mind are actually like four points. We have discovered, or the very first glass that it's found on the nature is called obsidian, and that has been found 75,000 BC. That takes it to the Paleolithic age. That's how old it is. Now, small glass articles have been found in ancient Egypt. And that's where most likely the glass was actually created. Also, another important point is that in 1950 through 1960, glass science became a very major research discipline. And then the float glass as we know it today, it was invented in 1959 in UK, actually. So this is just, Colleen, I don't know if you can hear me, but there are actually 2 people on the waiting list, and for some reason I cannot take that away from my screen. Thank you for admitting them. So this is how the glass manufacturing process, obviously in a very simple form, would look like. They have 3 big areas: the batch, the warm area, and the cold end, it's called. So batch is basically where the raw materials are preparing and mixed, and then it goes to the warm area. It actually has to be melted to 1,560 degrees Celsius. So after that, forming takes place, and then the cooling process. Now, on the cold end is where the cutting actually takes place. The result of all this is where the glass, the raw glass or annealed glass is created. And that is what all the manufacturing facilities, including the company that I represent, take from there. So really there is none like glass being made in our facility, but as you will see, there are many different processes and steps that has to take place before obviously we end up with a final product, which is the impact windows and doors. So now the glass is unloaded and stacked, right? The glass arrives into the manufacturing plants in large racks to facilitate handling. An overhead crane, because as you can imagine, this is very, very heavy, is used and unload the trucks and to move these racks from receiving to a staging area. Just so you know, also, depending on the type of glass, a stack of glass could cost up to $15,000. Now, these are actually the 4 different steps that once we receive the raw glass or annealed glass, also known as, needs to take place in our facilities in order to end up with the final product. The very first step in any glass treatment process is cutting the glass. So even before any glass is treated, either heat strengthened or laminated, it must be cut first. Only annealed glass can be cut. Once glass is treated, like once again, heat is strengthened or laminated, it cannot be cut. At this process, all these processes are made by CNC machines, which optimize the usage of each glass sheet. Almost 97% of all available shapes can be cut on XYZ cutters. As you can read here, the machines can cut at a rate of 7,000 linear inches per minute. That would translate to 35,000 linear feet per hour. This is this video shows how the overhead crane goes down into the aisle of a stacked glass that are separated by thickness and tins, and pick up the next piece to be cut with a series of 12 mechanical suction cups. And it then takes that large piece of glass to the first of the three tables. The tilt table that will take that piece of glass and lay it flat, to then be cut on the XYZ table. The video then shows the glass being scored at the rate of 7,000 linear inches per minute. It uses a diamond tip cutter that usually will allow for a clean break, but occasionally it will not, which at that time, then broken glass will go into a recycle bin and then cut another piece. The third table is where the technicians will snap the piece at the score lines that the XYZ cutters made. As mentioned before, the glass is actually scored, not cut, like many people will think. I used to think that way, by the way. So trim ages. Basically, because the tolerance and the impact related products are so tight, we need first to cut off the thin section from that large piece of glass to be assured that we have perfect 90 degrees corners. You will see that in the next video that I'll show you. But now, what do you think happened to recycled glass? Most people, myself included, as I said before, just a short while ago, that it gets sent back to the glass manufactured and melted to remanufacturing. But that, however, would be way too expensive. So it is sent to a local recycling plant for other uses. This is the breakaway table I was telling you about, where the technicians will snap apart the piece of glass that were just cut on the XYZ machines. Those orange sleeves being worked by the technicians, as you can see, are made out of Kevlar. Basically, it's the same material that bulletproof vests are made from. The piece of glass are then put into a cart or table that take them through a wash cycle. The original glass manufacturer put a powdery substance called Lucor. So this is just protecting the glass so it would not scratch to each other during the transportation, but now it has to be taken off. So the final step in the cutting process is slaughtering the glass into the hard cart. The glass is now taken to either the tempering, laminating, IG, or the manufacturing department, which a non-impact product could be made. During the tempered glass process, I just want to explain, is actually two things will happen. Either a heat strengthened glass or tempered glass will be made. As you can see here, as I was explaining, there are these two type of glass that have already been strengthened, right? It's the very basic is heat strengthened glass that is actually 2 times stronger than anneal glass or the raw glass as we know it, and it will break into bigger pieces, 8 to 10 inches big. It's used in a laminated product. It's not usually used by itself for safety reasons, of course. And then the fully tempered glass, which is 4 times stronger than anneal glass. It breaks into smaller pieces when fractured. This is what you will find in your car. So the tempered glass, so it can now be used by itself. And when, as I mentioned before, in non-impact products. And it is used in different areas because of safety reasons, once again, if you are having a non-impact product, right? So it says, it just start with a logo. The first stage that temper glass, now if you're going to go to the next process, goes through after being cut is the watermark or bug process. The ICC, which is the International Construction Code, allows for several different approved methods that can be used, such as the acid etch or laser etch. This is a requirement that both type of approved safety glazing has to go through. In windows and doors, the most commonly used place to put this is in either of the two lower corners. A belt sander is then used. This uses a double belt that hit both sizes of the glass edge in a single pass. In this way, the double belt sander rounds the edges of the glass, removing any splinter or sharp edges. This is done for two reasons. First, to make it safer for our technicians to handle it. And second, it seems the edges to keep even pressure within the glass edges during the tempering process. As you will see, the glass go through a lot of stress. So that is needed. This is obviously an exaggeration, but this is what actually happened during that seaming process. I don't know. Hold on a second. Thank you. Now, since the molecules on glass are not interlaced like a true solid, during the tempering process, while the glass is in a soft molted stage, air pressure is applied in the quencher to force some of those molecules closer and tighter together, thus increasing the strength. The only difference between the heat strengthened glass and tempered glass is the amount of air pressure applied inside the quencher. The bottom picture that you can see there is the air quench and after cooler all put in one. So once again, think about this. How many of you have ever seen tempered glass break? And think again, because I'll share some interesting information here. These are just some facts about tempered glass. Tempered glass has 10,000 pounds per square inch of pressure. During just one blink of an eye, tempered glass could break 100 times. And once it cracks at 14 times the speed of sound. So that is pretty quickly. That's why it's so difficult to actually see it breaking. After a piece of tempered glass breaks, it will continue to break for 3 days. The video here shows glass moving from the tempering oven to the quencher, showing how red hot it is. It is critical that all rollers be perfectly lined up and traveling at exactly the same rate of rotation. If one roller is rotating faster than the roller before it, this will cause the glass to stretch. Conversely, if that roller is in front of the is rotating slower, than the one behind it, it will cause a dip in the glass, much like a potato chip. So of course, precise and regular maintenance is very critical. These are one of the different tests that the glass goes through. Once the glass is cooled to an stable temperature, it is checked to determine how much, if any, wave or ripple might have been created during the tempering process. This is done through a combination of both visual inspection of the zebra pattern reflected of the glass and by the use of the light-centric computer. One of the bigger advantages of doing the tempering process by a company like ourselves is that it will give them the chance to better control quality. Here you can see the technicians inspecting the glass for defects as it travels under the zebra board. You can also see the two light-centric computer heads just under the zebra board that are analyzing the glass for inspections as well. Need to remember when performing this part of the process, you are manipulating the characteristics of the glass. There will almost always be some kind of slight distortion. Keep in mind, our company has a very strict glass quality criteria. It's actually higher than the national glass quality criteria, just so you know. The technicians view the results of the light-centric computer scan that read the glass for any distortion and or hotspots. Then it goes through the break test. As part of our quality control, a technical will perform a break test every time the glass changes a recipe, or every 14 minutes, whichever comes first. The glass recipe is what the furnace operator is telling the tempering oven what to do, what is coming up, you know, thickness change, color change, or size change. This is just a breaking test being recorded. As you can see, many different pieces there. Slotting and delivering. Tempered glass is then slaughtered in the appropriate carts and delivered by material handlers to the next phase of processing. Tempered glass can be used by the glass plants, the IG plant, or the assembling plant. Now we're gonna go through the laminated glass process. So what really is laminated glass? And here I really wish I could, you know, pass around some samples. But if you are interested, once again, in getting one small sample, I think those are like 3 by 3. And then it shows just a tail, a little tail of the inner layer. You can actually see the difference. The laminating process is the sandwiching of 2 pieces of glass fused together by a piece of either PVB, and please bear with me here, it's called polyvinyl butyl, or SGP, which is Sentry Glass Plus in the center. PVB, which is the more flexible one, is the most commonly used product in windows and doors and provide a better sound insulation, by the way. And the SGP is a lot more rigid, and this is usually found on doors and large size windows. This is just something that you can keep in mind, that we actually use always a 0.09 inner layer in order to meet our rigid testing for large missile level D. We do not manufacture level E, which is basically almost like bulletproof, but everything that we do is large missile level D. Now, this is a picture of the front of the laminating line in a glass plant. Receives glass either from the XYZ cutter or the tempering line, right? So you either have a raw glass or annealed glass, or you have a heat strengthened or tempered glass in order to create your sandwich, let's say. Oh, and this is an example of what the logo will say, or that little logo that, or bookmark also called, which is going to be on, usually on the lower right corner of your product. And the time and date of manufacture is actually not required by code, but is there as part of our own quality control system in case something goes wrong and we have to track the manufacturing process down. Now it goes to the vinyl, just like the glass did, has to go through the process of being cut. So the Eastman cutter It's an automated machine, very similar to the XYZ cutter, but now in this case, it's just handling the vinyl, right? One important thing to keep in mind is that the PVV and SGP arrives to our glass plant on a refrigerated truck, as it will start to self-process around 7 degrees Fahrenheit. As you all know, Florida is usually hotter than that, so we cannot take any chances. So there's just a lot of processes around this. It's just not as easy as delivering the materials and start working on that. If you look close at the photo on the right there, you can actually see the two pieces of 0.045 thickness pieces that are fused together to create a 0.09 on the case of the PVV. We actually do that ourselves, I'm sorry. And these are just some photos so you can actually see the difference between the PVV, as mentioned before, is a little more flexible, and this is definitely more common to see in any windows. And this SGP, which is the rigid one, that is usually used, as mentioned before, on doors or very big windows. This is the clean room. This is definitely a very important, unique, and how can I say, delicate process, because in this clean room, the two pieces will actually get together and create the laminated portion of glass at the end. So this process, just to give you an idea, is much like a grilled cheese sandwich, right? When you put a piece of cheese between two pieces of bread prior to applying any heat, you can rearrange, you can change without, the pieces without any problem. But once you apply some heat, then that will become one single product, which is the laminated glass. And then it goes to the press oven. The press oven is known as nib roller, and this function starts the adhesion process by heating up and compressing it. Glass exists at 135 to 145 degrees Fahrenheit. So it's pretty hot, but not to the point that it would melt, right? The press forces air out of the laminated unit, which is also very important. If any bubbles are created there, that is a defect piece of glass. We cannot take it out afterwards. Then the glass actually is stacked, and it will go to an autoclave cart. And I will explain in a minute what autoclave is. Now, the double thickness glass, which is that laminated piece of glass, weighs in at approximately 10 pounds per square foot. So the tracks are handled are handled by tracks that run through this part of the plant. And because each rack can hold 250 pieces of glass, the rack could weigh thousands of pounds, of course. So it's very, very heavy. So what is an autoclave? It's basically a giant pressure cooker, right? You will have to excuse me for a second. And during that process, different pressures and temperature occur. So all those pieces of glass, the racks that you just saw, will get in the autoclave and be baked, for lack of better term, during approximately 3 hours. After that, it will, the actual a laminated piece of glass is created. Let me see, and just hoping that this will work. Yes, it will. You will see how the autoclave basically closes. These autoclave machines are actually manufactured in Germany and takes up to 6 months to have them shipped. And this is what really is happening inside of the autoclave. The pressure there is 180 pounds per square inch, and the heat is 280 degrees Fahrenheit. It bakes, as I said, for approximately 3 hours. Once that process is finished, then you have a laminated piece of glass, and the inner layer is now, you can actually see through. Before that, it was opaque. But during all this process, you can, as I mentioned before, end up with an actual laminated piece of glass. Now it goes to the next process, which is trimming. Just like the grilled cheese sandwich example I was given, you could end up with cheese around that piece of bread, right? So this is what is happening here. We have to trim that extra vinyl around the glass. That is also important because it will, to do this at this stage, so that there is a maximum amount of glass against the glass bed of the door or window for a sealant to apply to hold into place. Because basically this is what is going to be set on that piece of, it could be in the frame. So it can be vinyl or aluminum, and it's very important that it sits correctly. So this also helps. It goes then into the final inspection. The final inspection is done at this point before placing on the hard transport racks and brought to the manufacturing plants to be placed in either windows or doors. If there are scratches, a glass weld system can be used to remove them. This is really not sanding, because as I mentioned before, glass is amorphous. It's really not a solid or nor a liquid. Because of that, and using this technology, the system, it can actually use the scientific makeup of the glass to rearrange the molecules. So basically, the glass can be fixed. And that's how it's done with that machine. Now, the insulated glass process. That would be basically the last part or of the processes, let's say, that we do in our plants. And that is what most of you would usually specify because of the great energy values that it can provide. So what is the IG, or insulated glass, as we call it? It's basically two pieces of glass with an spacer between them, creating that hollow space that can also fill with argon gas, by the way, which will give you the best energy value as well. These, as you can see, are two pieces of monolithic glasses. And these are the typical spacer systems. There are several of them: the thermoplastic spacer, the Duracell, and the super spacer. And then of course, we also have the laminated glass, but using not two pieces of monolithic glass, but one will be laminated and the one outboard, or also called sacrificial light, will be a monolithic glass. This is the most commonly used actually here in South Florida when you are trying to get the best energy values. But why would you do that? Because obviously it will be more expensive, let's say. It makes glass more energy efficient, as I mentioned before, while providing an impact resistant benefit. It also creates noise reduction, which is very important, and it's amazing the results that you would get with this. Makes it harder for hot or cold to move through the glass, and this is also critical in South Florida. And builders use laminate insulated glass to meet certain building codes and regulations. I just want to check how we're doing with time, but we are doing okay. Okay, so the insulated glass process, I'm sorry about that. It actually goes through two steps: the preparation and cleaning, and the building and caping. The spacer is applied to one piece of glass, and the mate is sent into the caping station. The caper then marries the two pieces of glass together, and when finished, the unit is sent to be heated and pressed at desired thickness. You can see here a little video. So at the end of the IG line, the monitor on the right has information about the piece of glass they are receiving, the size, thickness, and what slot the piece of glass goes into on the hard card. Someone is still getting in. Just so you know, the IG, as you can see there, the IG units are pressed at 100 to 120 degrees Fahrenheit, and then check for quality, temperature, thickness, color, size, etc. The unit is filled with air or argon gas, and then seal. The oven operator will then load the unit into the hard part in a certain production build sequence. When the hard part is complete, it will be delivered to the manufacturing department. Okay. The last three slides are actually more part of another presentation that goes very deep into the energy codes. But here, I just wanted to give a very fast introduction to these very important, obviously, information and fact and values that I'm sure you all are aware and need to, get certain values for your projects. So it's just, as I mentioned, an introduction or just a fast way of understanding the solar heat gain coefficient, the U factor values, the visible light transmission, but really, really quick. So basically, the U factor measure how well a product prevents heat from escaping. That is, of course, you know, for winter up north, but really for us, we're actually trying not the cool air from escaping, right? The smaller the number, the better the window system is at reducing that heat loss. So just keep in mind, this is more like golf and not like basketball or any other sport. You are actually trying to get the lower number, a lower number there. I don't know why this is not, okay. Then the solar heat gain coefficient measures how well a product blocks the heat caused by sun. So once again, the lower a window's solar heat gain coefficient, the less solar heat is absorbed by that window or door. And just so you have an idea about the, you know, low E, that is also very trending and a lot, I mean, many projects actually use it. There are two things that I want you to keep in mind basically with this. The low E glazing falls into two broad categories, the soft coat and the hard coat. But the most commonly used, and it's actually offered through our company as well, is the soft coat glazing, okay? And for very hot weathers like ours, the better low E placement is the surface number 2. The surfaces are actually going to be counted from outside of your building inside. So the number 1 would be the surface that we all see, touch, and it's basically you can see from the outside, and that is your number 1 surface. Number 2 would be obviously the inside side of that piece of glass. Okay, so if you are having an insulated laminated, you are actually having 1, 2, 3, 4, 5, and 6 surfaces. Always low E, it's better when it goes to surface number 2. I hope that makes some sense without showing it, you know, with that sample, it's actually pretty difficult. But anyhow, that is once again just a very rough introduction of that. If you're interested in not only in the energy code class, but any other class that we are offering, as well as it could be also product knowledge, you know, product knowledge of everything that we manufacture and we can offer. I will be more than happy to either do it online as we did today, or even as we slowly, you know, reopen offices and try to go back to some sort of normality. I will be there as well. I will be more than happy to stop by your office and drop some samples, etc. So once again, if you're still there, if you're still conscious, you haven't fallen asleep, let me know which one of these little guys you're interested in. I will be more than happy to mail it out. And this would actually take us to the final product. Of course, I wanted to show some beautiful pictures. Here, though, you can see all of these, for some reason, are actually residential projects. But please keep in mind, our company also handles mid-rise, high rises, and have plenty of options other than curtain wall. We can do it all, basically. I don't know if there are any questions that have been submitted, or if anyone would like to ask any questions right now. I will do my best to answer. If I do not know the answer, of course, I will get back to you as soon as possible. So opening, I guess, I don't know how I do that, Colleen. So go ahead and take over if you want. Hello.
Hi, if people want to submit questions, they can send them in the chat window right now if they have any questions. And other than that, we're good. I mean, unless you have more to present, people should send their, if they have not given us their AR and AIA numbers, they need to send them to the chat right now before we close the before we close the webinar. And if they want to receive swag from PGT, they should also send me their addresses, the firm, the name of the firm and the address. And and Marlene will send out some swag for you. But that's all I have. If you have any questions, I don't see any questions right now in the chat. But just please be sure that you send the AR and the AIA numbers if you want to receive credit for this course. So thanks a lot. We'll keep the information open and the webinar on for about another few minutes.
Okay, then, and once again, thank you everyone for taking the time and once again the interest today to learn hopefully something new. I really appreciate the time, as I said. And if you have any further questions later on, I think in the previous slide, yeah, there you have my email address, and mendez@cgiwindows.com. And as mentioned before, I actually handle the residential sector. But if you have a specific project, you know, high rise, I will be happy to pass it on to Jack Ritten, who is our specialist for that kind of projects. I'm here to help. Please don't be shy. Like if you need any corner samples or anything really from us for a presentation, we'll be more than happy to provide it to you. For example, if you have a presentation pending to one of your clients, we can provide anything you need. And of course, also remind you, we are now in ARCAD, where it's very easy to find all the CAD details, Revit. There is also a very nice tool where it will help you to basically create your specification. So reach out if you have any doubts, but there is all that information available for you. Okay, so thank you so much for the patience. As I said, the first time I've been presented to a screen, you know, to a computer right here. But I'm very excited, and thank you once again for giving us the opportunity to be here with you. Thank you, Colleen.
Thanks a lot, guys. Appreciate it. We'll leave the webinar up for just a few more minutes in case anyone wants to put in their information. So we have it. If you already registered with it, you don't need to put it in. We already have it. But just in case you did not, we could use it here. Thanks a lot.
Thank you once again for having us, Colleen.
Oops. Hey there. I think a few people are still on. I'm just waiting, and I will.
Sure. That's interesting. That's interesting. I said. So anyhow, next step, right, Colleen? It's you will be sending the information of our participants today.
I'm going to send you two things. I'm going to send you a thing of the chat, you know, that has all their information in it. So you have to kind of get out of the chat. And then I'm also going to send you an Excel sheet, which has all the registration information. So you'll have those two things. And then the third thing I'm going to send you is a link to the recording of the video.
Yeah, that will be somehow painful.
Ah.
I was counting with just kind of disappear, but I'm glad I got the opportunity. So thank you once again, Colleen.
Yes, of course. What I'm going to do is I'm going to stop recording. First of all, where's the recording?